Hello everyone. Today we're going to be talking about non-permissible values, also known as NPVs. Now this is going to be for fractions. We're going to create another video for radicals. So for this one here, when we're talking about fractions, also call them rational functions. For this one here, we first need to talk about what does non-permissible values mean. So if you think about the word non-permissible, right, that means not allowed. So non-permissible is the same thing as not allowed values. Now, when we think about fractions, what is the one restriction that we taught about fractions? The one rule, or the one thing that we cannot do, is that we cannot divide by 0. So for this one here, the one restriction for a fraction is you cannot divide by 0. So that is the one restriction we're going to be using in order to find out what the NPVs are going to be. So again, if we cannot divide by 0, then that means that our NPVs must come from the denominator only. Because the denominator is the bottom of a fraction, so that's the only part that could cause troubles if it ends up being 0. So let's take a look at a couple of examples to try and figure out how do we find and write out the NPVs. So we'll take a look at some easy ones and then we'll get to more complicated ones in a moment. So the first one here says find the NPVs. Number 1 says 7x plus 3 divided by 4. So again, for NPVs, we take a look at the denominator and see if it can possibly be 0. In this case, 4 cannot be 0, so the first one has no NPVs. Or you can say that there are none. Number 2 here says 2 plus 3x over 6xy. So again, our goal here is to figure out when will the denominator potentially be 0, and that's going to be a problem. So first of all, when it's nicely put together like this, 6 times x times y, we take a look at which ones would cause a problem. For example, 6 is not a problem because 6 cannot be 0. X, however, could be 0, so then that would make the whole denominator 0 since we're multiplying. So the NPVs for this one here would say that x cannot be 0. That's basically cannot is written as an equal sign with a slash through it. Also here we see that if we times it by y, if y was 0, that would also cause a problem. So we also have to state here that y cannot be 0. So that would be the NPVs for the first two examples. Now for these ones here, we're not going to solve it. We're just trying to look for the NPVs. So again, when it's subtraction or addition in between, we take a look at the denominators and we try and figure out which one's going to be a problem. So for this one here, what we do notice is that the denominator of x plus 4 could be equal to 0, which is a problem. Also, x minus 8 possibly could equal to 0. So how we would normally solve it would say that x plus 4 cannot equal to 0. And then we solve for x using algebra. So I want to get rid of the 4. I subtract 4 from both sides. And this tells us that x cannot be negative 4. So in my NPVs list, I can write down x cannot be negative 4. The other one, same thing, x minus 8 cannot equal to 0. So again, I'm trying to solve for x here. Add 8 to both sides, and we get that x cannot be 8. So we also add that to our list. X cannot be 8. So that would complete listing out the NPVs. Let's take a look at example number 4 here. So always try and factor your rational functions, because when you factor, that'll tell us, what are we looking at and how do we figure out which components might be 0. So ideally, after you're done factoring, you might get something like this. And again, the NPVs only come from our denominator. So we have 1, 2, 3, 4 potential NPVs that we need to write out. So we can again solve for each one, like so. X minus 2 cannot equal 0, plus 2 to both sides, x cannot be 2. And the more you do this, you'll find out that if it's simple like this, then we can just write out that x cannot be 5, because it's kind of the opposite of what you see. And the next one would be x cannot be -1, and the last one is x cannot be -3. Now, some teachers will require you to list them out from smallest to biggest. So in this case here, you then say NPVs would be that x cannot be, and you can write out like a list. So the smallest one was -3, then -1, then 2, then 5. That would be the NPVs for this one here. Now, our last example for this video is about dividing fractions. So something for you to keep in mind here is that we understand with fractions, when we see division, our goal is to change it to multiply, and then we flip the second or the back fraction. Now, keep in mind here that NPVs are always about the denominator. So in the beginning here, we can see we can list out the denominators and list out our NPVs. But when we do the flipping step, you'll notice that because we flipped it, we potentially might get some new NPVs that we need to add to the list. So let's run through this example and see how that works. So first of all, when we begin, we see here that we have this one, this one, this one, and this one, since all four are the denominator. And when we solve for them, we can see here that x cannot be -6, x cannot be 3, x cannot be 2, and x cannot be -3. None of them repeat, so therefore these will all be in our list for NPVs. Now we know that our usual next step now is to flip our fractions in the back only when we change the divide to a multiply. So let's take a look at what happens here. The front one we would then leave alone because nothing happens here. I'm just going to rewrite it for now. So this all stays the same. But the moment I change it to a times, I need to flip my second, or the fraction behind the division sign. So now x minus 2, x plus 3 come to the top, and x plus 8 and 2x minus 1 go to the bottom. So as you can see here, our numerators now became our new denominators, but those new denominators could create new NPVs. And of course, when we try and figure that out, we do notice that we do get 2 more new NPVs. So we know from this one, it's just going to be x cannot be -8. When the lead is not a 1, it might be a little trickier, so it might be better for you guys to still write it out. So 2x minus 1 cannot equal to 0. And again, we do the algebra here, add 1 to both sides. 2x cannot equal to 1. And then last we divide by 2. So this tells us that x cannot be 1/2. So now we have to list out our NPVs from smallest to biggest. So again, take a look at how many NPVs we have here. We have x cannot be -6, cannot be 3, 2, -3, -8, and 1/2. So again, if your teacher is picky about it, we do need to list them from smallest to greatest. So NPVs, in this case, they're all x's, so I can list them out as x cannot equal 2. The smallest being -8, then -6, then -3, then 1/2, and then 2, and then 3. And that would cover all the NPVs that we're going to get for this type of question. I hope this video has helped you figure out how to find the NPVs algebraically and when to determine you might get more NPVs. Do be careful about that division type because there could be additional NPVs that you need to list out as well. Now, NPVs are useful because they tell us if the answer that we solve for in the future to check with this list of NPVs, right? These are values that I'm not supposed to be allowed to be getting. So if my answer somehow matched one of my NPVs, I know that we'd have to reject that answer. And then a rejected answer is also known as extraneous. Extraneous meaning extra, so that one doesn't work. So we call them extraneous. So if you found this video helpful, please make sure to like this video and also subscribe to the channel to support us and keep improving your math knowledge. I'll see you guys in the next video. Bye.